Okay, guys, take a seat. Okay, so we're gonna start, guys, now. So good afternoon, everybody. So I sent you an email about the plan, what we are gonna do until the end of the semester. Do you have any question? Anything is not clear? I wanna clarify or something like that. So what I said, we're gonna have a lecture today and Wednesday as normal, and we're gonna finish this chapter. Also, Friday, we're gonna have a lab session. I already posted a lab online. I told you this lab is optional, it's bonus. I recommend you to do it because number one, it's very easy. As you will see today, just a little bit modification to two programs here. Number two, I also recommend to do it because this is gonna be, you are gonna do timer system. So you are gonna learn how you program timer system, okay? And it's very easy, just one program, you will run it, okay? So I recommend you just to do your best. It's bonus anyway, because this is a dead week. I know you are busy in too many things. If you don't want to do it, that's okay. But I encourage you to do it. This is number one. Okay. Also Friday, if you finished your project and you want to demo it, you can demo it. Okay. If you need help from the TAs regarding anything in this course, you don't understand a topic, or you wanna some help in your project, whatever. Also, you can come on Friday. Is that okay? I sent you the exam. Your exam. I think is gonna be Monday, right? From 1 to 3. Okay. It's gonna be 2 hours. Again, it will be similar to what we did before. It's gonna be open notes. You can use assign any printed material should be okay. Okay, but you should not use electronic devices. That's it. Okay, it's gonna be 2 hours. As I told you before, I'm gonna give you two questions, one in assembly and the other one in C. Okay, and I ask you to program it. Okay, so it's gonna be like two applications. Okay, so for similar to what we did before, it's application. For example, I'm gonna tell you, you have a sensor, read temperature, convert the temperature to ASCII, display it on the LCD. So how can you prepare for the test? Very easy. All what you have to prepare is, I'm not going to bring something new. I'm going to just bring in the question what I taught here. Okay. So for example, you will need, for example, to use LCD. So you should already know how can use LCD. Okay. If I give you a question to use LCD, you should know how to do it. Is that okay? Same thing for 7 segment. Okay. Same thing when you convert binary to decimal to binary. So if you already know how to do these blocks, it's like blocks. If you know how can you do these blocks, okay, you should be okay, because the exam will be similar to what you did before, okay? Because it's open book, maybe it's gonna somehow challenging in time. It should be easy, it should not be difficult, but it need more time. So maybe, okay, I will try to make it reasonable, but still I have to balance because it's open book. You got what I'm saying? So that's it. You already have all your material. It should be okay. The only concern I usually have is some students only focus on one language and leave the other language completely. Okay, so this is very dangerous because you don't know. Maybe the question, maybe if you don't focus on assembly, maybe the question in assembly is easier than C, or maybe the opposite. So you should. My expectation, as I said from the very beginning, you should know the two languages equally. So I'm going to give you two applications. I'm not going to give you the freedom. I'm going to tell you, program this one in C, program this one in assembly. But usually, what I do, because I know assembly needs more time to program. So if I have two applications, one is easier than the other. So usually what I do, I ask you to program the easier one in assembly. okay? Because I know assembly needs more programming, okay? Anyway, the most important thing is, okay, when I program the final exam, this is the way I program it, okay? To solve this problem, you have to do, number one, you have to initialize the LCD, you have to program LCD. Number two, so I put some kind of tasks, okay? So at least what I'm saying, at least if you, even if you don't figure out how can you solve the whole question, at least to do your best, at least to try, okay? Because if you write nothing, I'm gonna give you 0, right? But if you try, but you have to try in the correct direction, right? So if you, what I mean by try is, again, if the question is LCD, okay, so what I do, I put some mark on the LCD. Do you use the LCD correctly? Do you convert the binary to decimal or not? So I put a certain tests, okay? At least I'm quite sure, even if it is hard for you to program the whole application, but I'm quite sure you can do some tests because that's what I put in the course. Is that okay? So anyway, so also for the project, you should. I told you on Wednesday, December 9, you are going to have the demo slots from 1 p.m. to 4:45 p.m. I have the sign-up sheet here. Is that okay? So you can select the time slot. So I just write your name here. Okay. Also, during the demo, you have to bring your board back. You have to bring your board back because if you don't bring your Dragon board, you are not going to be allowed to demo. Is that okay? We will need our board back. This is one thing. Another thing, you should print your report, project report, and give it to us. Okay. If you go to the course website, okay, guys, quickly, because I want to answer. Okay, so what I'm saying, if you go to the course website, I write on the course website what should be in the report. Is that okay? Any question, guys? I need one report from each group. Only one. Yes.
Can we just demo this Friday as well?
You can. Yeah, that's what I said. You can demo Friday. Yes. Okay. Yeah. Okay. So let's start today's lecture. So what I did so far in this chapter 5. I told you we have timer system, as I said before, okay? Quickly, I just want to make a very quick revision before I start the programs I want to teach you today. So I told you, in this chapter, I should teach 2 things. Number 1, the timer system. Number 2, the pulse width modulation. For the timer system, I told you we have 80 channels. Every channel can act as input capture or output compare. Every channel has 1 pin in port T. Every channel, okay, every channel can trigger interrupt. That's why you can see here 8 interrupts. Also, we have 1 counter, 16-bit counter. Okay, only 1. We don't have 8. Only 1. Okay, this one also can trigger interrupt. We call it overflow interrupts. Is that okay? And then I explained here quickly because I already mentioned this one before. Okay, I explained here. TCNT. TCNT is a register. This register, TCNT. This register should have the value of the count right now. So this is the counter, okay? So if you want to know what is the value of the count right now, it's in TCNT. So TCNT is periodically updated, okay? And I told you before, what is the speed of the counting, okay? What is the speed? I told you we have a square wave this way, and this square wave should be 24 megahertz divided by breath scale, and you can program the breath scale, okay? Every time there is overflow, as I said before, you trigger timer overflow interrupts, okay? You can calculate the time of each count because you are gonna need it. You need to know what is the time for each count, which should be 1 over F. And F should be 24 megahertz divided by the breath scale you select. Breath scale can take a value from 1 to 128. Is that okay? So it's up to you. You can program the breath scale. Is that okay? So by this way, you can know the time for only 1 count. Okay. I told you input capture. This is how input capture works actually. Input capture. We have a pin. As I told you, there is a pin here, PT from 0 to PT7. Okay. Every time there is an event here, every time there is an event, what's going to happen, the current count is going to be recorded. The current count is going to be recorded in a register, TC. And for TC, we have 8 TCs. So every channel has a separate TC. Okay. So this one is going to be recorded. Number 2, interrupt is going to be triggered. You will see today. Okay. What should I write here in the interrupt subroutine? So I'm going to teach you today. But first, what do you mean by event? Every time there is event, what do you mean? What I mean, as I explained before, it can be falling edge, it can be rising edge, or you can program it to capture both. So every time there is rising or falling, you can trigger interrupt. So you can program it this way as well, okay? So, and I made it very clear, input capture is used if you want to measure time. For example, you have a signal like this one, and this is in the lab, and this is what I'm gonna teach the program today. You have a signal like this one, and I want to measure the time from here to here. Is that okay? Or I have 2 signals, as you see here. I wanna measure the time difference between them. Or you have a signal something like that, and you wanna measure the time from here to here. So measure time means input capture, period. Okay. So input capture is used if you wanna measure time. Okay. If you don't want to measure time, I can use input capture as well, like IRQ. And this I explained last time a program. How can you use input capture like IRQ? Because it's very close. Think about it. What is IRQ? IRQ, every time we have event, I should have interrupt. Okay, that's exactly what we're doing here. Every time there is event, we're gonna have interrupt. That's exactly, okay, but here we do one thing more, okay? Also here, we record this account in TC. Okay, I'm gonna ignore it. I'm not gonna use it. Okay, if you wanna use input capture as IRQ, okay? So for output compare, I told you every channel can work as, you have to program it as input capture or output compare, okay? For output compare is used if you wanna generate a signal, something like that. You wanna generate a signal like this one, okay? So the way it has to work is, this is how output compare works, okay? Number 1, I have to write some value from TC. I have to write some value in TC3. Okay. If you see here, it's a little bit different from this one, because here, this value is going to be written, and usually I have only to read TC, because the time of the event or the count of the event is going to be written here, and in some subroutine I have to read. I'm not going to write. I have to read. Okay. This is here. But here in output compare, I'm not going to read. I'm going to write. Okay, because it's different. So here, I have to write some value here. I have to see what is the current value of TC in G, okay? And then I'm gonna add some value, for example, 900 or something like that, okay? For example, from here to here, it's 900, okay? So this value is TC in T. TC in T gives you the current count. So the current count, I'm gonna add a certain number of counts, for example, like 900, I'm gonna write the result here, so the result here. Once they are equal, 2 things should happen. Number 1, we have interrupt. Number 2, action has to be taken on the pin. Okay. For example, I have a very good example here, and I'm going to give you the complete program right now. Okay. For example, I want to generate a signal like this one. So we're going to have interrupt here. We're going to have interrupt here. We're going to have interrupt here, and so on. Okay. So once I come to here, okay. So first, the action, you can keep the action toggle. Okay, so that means every interrupt, the pin is gonna toggle. So you can make it toggle all the time, okay, in this case. So this interrupt is gonna toggle, this interrupt is gonna toggle, and so on, okay? You can make it toggle. However, maybe if there is like misalignment, you can generate something like that. It's gonna be something, so you have to be careful here. Okay, so if you make toggle, it depends on how you start. If I start from low, okay, so I toggle high, but you start from high, you are gonna toggle low. So if toggle doesn't work with you, it's very easy. All what you have to do, once I come here, I can change the action. Next time, I can make it low. Okay, so I'm gonna clarify it now. Okay, so but let me. So what's gonna happen here? This one has to be 300 microsecond, and I know
the time for each count 1/3 microsecond. Okay, I know this one because it's f1 1 over sorry, so because it's this one should be 1/f, and f should be 24 megahertz divided by the prescale. So after I do the calculations, I found that this is the time for one count. That means this is 300. So that means 300 microsecond divided by 1/3 microsecond. The result should be 900 counts. Okay, so what's going to happen? Once I come to here, I'm going to say in the interrupt here. Okay, I'm going to say that's what you will see today. TC0. Okay, if you use the channel 0, should equal TCNT plus 900. Yes, you have to do something like that. Same thing here, but here I'm going to say TC. I'm explaining quickly because this is a revision. TC0 equal TCNT plus 2100. Why it is 2100? Because this is 700 microsecond. If you divide 700 microsecond, if you divide it by 1/3 microseconds, that means from here to here it has to be 2100 count. Okay, what I'm saying is, okay, so what's going to happen? That's what you will see today. What's going to happen? Every time I have interrupt subroutine, okay, I need to check. I am here or I am here. Is that low or high? So I need to check. Okay, so that's why you'll see that right now in the program. So that's why I'm going to use a variable. Okay, this variable is going to tell me I am low, I am here. I'm high. Okay, I am low and or high, and so okay. If you are high or low, so I need to use that variable because if I am here, that means I have to use this one, and if I am here, I have to use this one. Yes, so I'm gonna do something like if statement, something like that, to see if I'm here or here, and then I'm gonna use this one or this one. Is that okay? Now, regarding action, you can use toggle. If it works with you, that's okay. If it doesn't work, toggle. Because the risk is the following. Look here, guys. It's the beginning. So if I start from low and then toggle, so you are gonna get something like that. But if you start from high, so you are gonna get something like that. Okay. For sure, I need this one, but this is wrong. Okay. So there is another way. If you just to be on the safe side. Okay. What is the other way? I'm gonna tell you what is the other way. Here, if I am here. If I am here, okay, guys. So number one, I'm gonna write this one. Number two, I'm gonna make the action. Okay. So here one. So I'm gonna say next time the action has to be low to make sure that next interrupt is gonna become low. You understand what I'm saying? So once I come here, I'm gonna say the action is high. Action is high means next time. Okay. Next interrupt. This one will become high. So I think this, if there is some risk, if you make it toggle, maybe there is some risk you generate the opposite of the signal this way. Okay, I think we did it. You will do it on Friday. I think we did it using toggle and it was okay. But maybe in other scenario, in another way, if you start from high for some reason, maybe you have something like that. So I recommend to be on the safe side, okay, to be okay. I think it's better to be specific. Once I come here, what should be the action for the next one? Once I come here, what should be the action for this one? Okay, toggle is somehow risky. Okay, so anyway, I already explained your programming. I don't have time to repeat what I said before. I already explained this one. Okay, it's just a bunch of registers. All what you have to do, you have to set very easy. Okay, it may be, to be honest with you, maybe it's just many registers, okay? But it's easy. Why it is easy? Because if you can program it one time, all the time almost again is the same. Maybe there is some small variation. You may change some numbers, but almost everything will be the same, okay? So here, so I'm not gonna spend more time on this one, okay? So I already explained, it's just a bunch of registers. Based on the values you put here, for example, this one, input capture, output compare, every bit here, you have to do it to program. You want to use the channel input capture or output compare. This one for enable bit, this one for interrupt flags, and so on. So I already explained. This one here for the action, as I said before. So these two for channel 0, these two for channel 1, and so on. What action you want to take? That's what I was explaining right now. So if you want to do toggle, if you use the channel 0 and you want to toggle, so you're going to use 0, 1. Okay. If you use the channel 0 on this register, because here I'm using 2 registers in this one. If you want to clear, so if you want to clear, this is pull. If you want to pull low, so you can use this one, 1, 0. If you want to pull high, so you have to use 1, 1. Okay. Here, this is for input capture. So here I'm going to have 2 registers, as you see here. Is that okay? So this one, you can capture rising edges only. So here, for example, again, 2 bits for each channel. So I'm going to use this one if I want to capture rising only. This one is going to be used if you want to capture falling only. This one if you want to capture both rising and falling. Is that okay? Anyway, so let's, and also I explained in C language, we have a number. I already here also make a summary. What registers you have to set here. Again, you have to be smart. Listen to me, guys, because really that's not good. For example, here I give you example on the channel 0. Okay. If I tell you, for example, in the exam, use the channel 5. Okay. Some student just to copy this slide. Okay. That's bad, very bad, right? Just to copy what is there. Okay. This is for channel 0. Okay. Yes. For channel 5, you have to do the same thing. However, you may need to change these numbers, because these numbers are for channel 0. Okay. So for channel 5, you have to change these numbers. Okay. Anyway, for C language, you use a number of functions. I explained them last time. A number of functions. Also, you can do like assembly, and you can manipulate, or you can set the registers this way. Okay. Anyway, and also I told you in the interrupt, similar to what we did before in IRQ. Remember, we used number 6 for IRQ. For RTI, we are going to use number 6. We already used number 7. Same thing for channels. So here for this channel, we are going to use 8, 9. For the timer overflow, we are going to use the number 16, and so on. Okay, because this number, you remember the number you use interrupt, and then you void, I think, void interrupt, and then you put a number here. This number should tell the C language what this interrupt subroutine is for. Okay, that's why you have to use these numbers. Okay. Anyway, so last time I explained how can we use input capture like IRQ. Today, I'm gonna start from the next one. So here I want to measure time. Okay. So here I explained to you 1 programs, one in C and the other one in assembly. Okay. So I'm gonna start with C first. They are exactly the same thing, but this is in C and this is in assembly. Okay, guys. So let me tell you, I think I explained this story before, but let me repeat it quickly. Look here. Let me tell you the easy case, the very easy case, and then I'm gonna tell you what should happen in reality. Okay. The very easy case. This is a counter. This is T, C, and T. Okay. For example, you received. I want to measure the time from here to here. So this one, this rising. It came at time number 5, and this one came at time number 20. Okay, so if you have 5 and 20, so that means from here to here, it's 20 minus 5, which should equal 15 count. Okay, so now I can measure this time in count, number of counts. Okay, so now from here to here, I should have 15 counts. Is that okay? If you want to convert this count to times, that's easy because you already know what is the time for each count. So you can multiply it 1 over f. Is that okay? Because you know the time of count. Okay. In the coming lab, I ask you to measure the time and display it on the LCD. So if you want to measure the time in number of counts and you can show to me the number of counts is correct, that's okay. That's okay. Okay. So what I mean, for example, if I have 15 count and multiply by 1 over f, and then I know the signal, I know what is the time. This time should be very close to the time here. Is that okay? What I'm saying, this is an easy case. It's not always like that. Okay, I'm not gonna count on this one. In reality, what may happen is, this is TC in T. Look here, guys. Again, I'm gonna count from 0, 0, 0 to 1, 1, 1, 1, 1, and then another round from 0, 0, 0 to 1, 1, 1, 1, and then another round from 0, 0, 0 to 1, 1, 1. Okay? Maybe I'm gonna start from here and then I'm gonna end here. This is one possibility. Is that okay? So I cannot just get the difference because, for example, I'm gonna start from 700, I'm gonna end at 5. You got what I'm saying? So you cannot just get the difference. The difference is not gonna give you, I need to know, I need to add this part to this part, okay? So you cannot just subtract, okay? Maybe I'm gonna, if the signal is long, for example, I'm gonna start from one value here, and then I'm gonna have here one overflow, okay? And then I'm gonna have a second overflow, and then I'm gonna have the, for example, here 70, something like that. Okay, guys? So how can I count the time? I'm gonna tell you, very easy, very simple. I have a formula. All what you need in this formula, this one we call it edge one. The count for edge one, each one. Number 2, this is number 1. Number 2, I need to know how many overflows I have. This is number 2. Okay. Number 3, I need to know this value. That's what we call edge 2. The count here, the count for this. If you have this 3, okay, where at what count this one came, at what count this one came, and the number of overflows. So I'm gonna have an equation. You can plug in the equation and you can get it. Okay, that's what I'm gonna explain now. So what happens actually is, listen to me. Before I choose the formula, what happens is, in one interrupt, so I need 2 interrupts. One interrupt here and one interrupt here. Is that okay? In one, this is for a channel. So for example, for a channel 0, okay. In case of interrupt 1, so I need to know if this is interrupt 1 or 2, right? In case of interrupt 1, I'm gonna have a memory location. I'm gonna call it edge 1, and then I'm gonna put TC here. For example, TC0 here. Okay. So you give me the timer is gonna give me this count in TC. I'm gonna take it and I'm gonna save it in memory. Why? Because if I don't do that, when this one comes, it's gonna be overrated. I'm gonna lose it. Okay. That's what I'm gonna do. If it is interrupt 2, so I'm gonna say a memory location. I'm gonna call it H2. I'm gonna put TC0 in this one. Is that okay? So this is in channel 0 interrupt. Also, I should have another interrupt coming from the timer overflow interrupt. Okay, the timer overflow interrupt should count how many overflows we have. Okay, this is how it is. Okay, so I need to count how many overflows I have. And this counting has to start after the first interrupt. Is that right? Because I need to know from here. Okay? So after the first interrupt here, I'm gonna enable interrupts, timer interrupts. Because after, okay, so here interrupt 1 here, interrupt 2 here. Before interrupt 1, for sure timer overflow should be disabled. Why? Because I need to count how many overflows from here. That's why at this moment in interrupt 1, I'm gonna enable timer overflow interrupts. Okay. Also, I'm gonna have a variable. I'm gonna call it overflow. I'm gonna put it 0 in the beginning, and then every time there is overflow. So here, this is the timer overflow. I'm gonna increment this overflow. So I'm gonna say overflow should equal overflow plus 1. So every time there is one interrupt, I'm gonna increment it because I wanna count from here. Once I come here, for sure I have to disable interrupts, timer overflow interrupts. Otherwise, this value is gonna update it. It's gonna change. Okay, until I do the computation. You will see right now. Okay. So anyway. So let me tell you the conclusion in 2 sentences. The first sentence is, in order to calculate the time, I need 3 values. Number 1, the count, okay? at the first edge. Number 2, the count at the second edge. Number 3, the number of overflow. I need these values. Once I have these 3 values, I'm gonna plug in the equation to get the time. Is that okay? This is number 1. Number 2, here I need to use 2 interrupts here. I need to use one of the channel interrupts. I need also to use the timer overflow interrupts to count how many overflows we have. Okay, you will see right now. Here I need to know if this is interrupt 1 or interrupt 2, because in case of interrupt 1, I have to do 2 things, as you will see. I'm gonna say H1 equal TC0. Also, I'm gonna say H2 equal TC0 here if it is interrupt 2. Here also I have to enable interrupts. Here I have to disable interrupts here. Okay, because once I come to here, I should not, there is no, the overflow, the variable overflow should not be updated, because the overflow, I need to count overflows from here to here. So enable here, disable here, okay? And then after I do the computation, if I want to go for another round of measurement, if I want to measurement again, so I have to enable again. So I have to repeat everything again, so that when the first edge comes, I'm going to enable and so on. Enable interrupts to repeat again. Okay, so we'll see right now. So let me first explain the formula I have, okay, and how it is calculated. Look at the formula here, guys. We have 2 cases. This is the formula you have to use, okay? That's what I said. Here, this is the input capture. This is the timer overflow. Interrupt subroutine. All what I'm gonna do here, I'm gonna increment the overflows. Here, I'm gonna say H1 equal TC0 if it is first interrupt or second interrupt, okay? And then, once I have this number, 1, 2, 3. So once I have these 3 numbers, now I'm gonna use this formula to calculate the time, okay? So how you get this formula? Look here, guys, there are 2 cases. One case, if H2 is greater than H1. So I started from here. I started from a small value and then H2, okay? So this is the first case, if H2 is greater than H1, okay? So in this case, what happens, look here what happens. If I'm gonna start from here, and then once I come here, and then all the way, look at the first, because the problem in the first overflow, you will see now. Oops. Okay, guys. So look at the first. The problem is only in the first overflow. So let's see here. I'm gonna start from here. I'm gonna come here, overflow, and then I have to come to here. Is that okay? So how much is the count now? So this overflow should be 2 to 16 because I made a complete round. Is that okay? So now it has to be 2 to 16 plus this difference. Okay? Is that okay? So yes, that's how it is. Okay. What if I make 2 overflows? 2 times 2 to 16 and so on. So the first overflow has to be counted, okay, as 2 to 16. I'm saying that because when I explain this case, you will see right now it's different. The first overflow is not going to be a complete round. That's why it's not going to be 2 to 16. You will see now. But let's focus on this case now. So here, if H2 is greater than H1, this is the formula you have to use. Every overflow have to multiply by 2 to 16 because it's a complete round plus the difference. This one. Is that okay? Okay. This is the other case. Okay. You will understand what is the problem here in the first overflow. You will understand what is the problem in the first overflow here. Okay. Look here. Here, I'm gonna start here. Look, guys, and then I'm gonna trigger overflow here, and then I'm gonna stop here. So now overflow is 1, right? Because I triggered, there is timer overflow here, right? However, this timer overflow is not going to make 2 complete rounds. It's not going to be 2 to 16. Is that like this one? Here I start from here, so I'm going to make a complete round, right? Here no, because this one is bigger, so I'm going to start from here. So the first overflow should not be counted, right? Because it's not a complete round. Okay. So how can we? So how can we deal with this one? Okay. The way you can do it is, look here. I give you 2 formulas. Both of them are okay. So for example here, so for example, I can say overflow times 2 to 16. Is that okay? So I'm going to see how many overflows I have, 2 to 16. However, the first overflow should not be 2 to 16. The first one, I have to cut this part, okay? Because the first overflow, it was not a complete round, okay? That's why I'm saying you can say overflow times 2 to 16, but take away the difference this part, okay? Because this overflow is going to be 2 to 16. However, it's not a complete round, okay? So I'm going to take from here to here, okay? But I'm going to cut this part. This is one way to do it. Another way to do it is, look here, guys. No, I'm not gonna do this way. What I'm gonna do, I'm gonna, so the first idea, I got here, from here to here, 2 to 16, and then I subtracted this part. This is the first idea. Second idea, no, what I'm gonna do, I'm gonna calculate this part, and then I'm gonna add it. That's why you can see here, overflow minus 1 times 2 to 16, okay? And then I have to add this, not this part. I have to add this part, okay? This part here, okay? And that's what shown here. Anyway, just I explain how it works, okay? However, it's very easy. You just have a formula, just plug in. All what you have to do, just to get these three numbers, plug in the formula, okay? I want to tell you something interesting here. How I can get this part? You told us, okay? I have in the first overflow, it should not be counted, the first overflow, because you start here and then you stop here. That's true, okay? However, you have to get this part. How can you get this part from here to here? I'm going to tell you something interesting in the binary number, okay? If you don't understand it, it should be okay, but I'm gonna tell you something interesting in the binary numbers. Okay, quickly. I think I have. Yes. And look, I just wrote some numbers here. Look in binary numbers here. If you have, for example, I'm going to consider easy case 3 bits. So I'm going to start from 0, 0 to 1, 1, 1. Okay. So total, how many numbers we have? 8. 2 to 3, right? That's what I said. Okay. So total we have 8. Okay. So for example, if I start from 2, for example here, for example, this is 2 and this is 4. Is that okay? So the difference from here to here is 2, and the remaining parts, that's what I'm looking for. The remaining parts here should be 6. Is that okay? So now the question is, given 4 and 2s, because that's what we have. I have 2 and have 4, right? Given 2 and 4, I can get 2 easily, right? Okay. However, how I can get the reset? Let's set this part, which is 6. Okay, how I can get it? I'm going to tell you how. Okay. What happens is that if you want to get the difference, which is 2, so I'm going to get the bigger number, take away the smaller number. So I'm going to take the big one minus the small one. So the result is 2. So you can get this number. Okay. However, if you want to get this part, and that's exactly what we want to do here, if I want to get this area, which should be 6 in this case, the way I can do it, I'm going to get the small number, which is 2, take away the big number, which is 4. So 2 take away 4 should be minus 2. Minus 2, which is 6. Wow. This is too big to swallow. So how minus 2 is 6? Okay, I'm going to tell you how minus 2 is 6. Minus 2 is actually, minus 2 is 0, 1, 1. Okay, so if this number, if you see this number in unsigned number, so this one is going to become number 6. Is that okay? So minus 2 is actually, it is 6. This is because it's like modulus. It's going to add 8 every time, but anyway, that's okay. So what I say, this is going to work for any number. Okay. So let me tell you the conclusion. The conclusion, what I want to say here, guys. Look here, guys. The conclusion is, if I want to get, for example, this is 2 and this is 4. Okay. If I want to get how many counts we have here, I'm going to get the big number, which is 4 minus 2. Is that okay? If I want to get this part and this part here, okay? So the way I can get it, I'm going to take the small number, take away the big number, which is minus 2. And minus 2 is actually 6. It's going to be these 2, okay? Because in one case, I'm going to do this one. In one case, I need these 2. Okay. Anyway, it's try some numbers. It's somehow interesting. However, I don't want to spend too much time here. So the conclusion is, guys, your program has to get 3 numbers. Your program has to get H1, H2, and then it has to get overflow. And then you have a formula here. I spent some time to explain how we made this formula. Okay, try to understand it. However, you can just use it, but it's not difficult to understand. Okay, now let's see the program. I will start with C first because maybe it's shorter, easier to teach, and then I'm gonna go to C. Okay, so let's start here, and that's what you need in the coming lab. In the coming lab, you are gonna do measurement, and then you are gonna display it on the LCD. So all what you have to do here in this program, all what you have to update in this program, just you have to add a code. You have to add a code to display in the LCD. That's it. Okay, so once you get the measurement. Okay, there is another thing I forget to. You have to do 2 things here. It's a coming lab to update this program. Very easy. Number 1. Here I'm gonna do one-time measurement. So you have to make it periodic. Okay. So I'm gonna tell you how. So this part has to come inside the while loop here. Okay. So it has to be periodic. It's not only one time, but this program is only for one time. Okay. Number 2, which is easy. Once you get the measurement, you have to display it in the LCD. That's very easy, right? So, okay, so that's the only 2 modifications you have to do in this program. Okay. And then you are gonna input a signal. And then you are going to measure the time. That's it. Okay. So let's see how this one works, guys. As you see here, I'm going to define here. I'm going to define variables H1, as I told you, H2. Also, I'm going to define what I call overflow. Is that okay? I'm going to define them global because I'm going to use them inside the main program. I'm going to use them inside the subroutines. That's why they should be global outside here. This is number 1. Okay. Number 2, this is the result after you calculate the period, after you calculate the time. The result will be here. This is in the coming lab. You have to take this result and you have to display it on the LCD. That's all what you have to do, right? Number 2, also I need a variable to know if they interrupt 1 or interrupt 2, because I told you I need to know if this interrupt 1 or interrupt 2. Is that okay? Because interrupt 1 here, interrupt 1 here, interrupt 2 here, okay? I have to do something here, I have to do something here, okay? So I need to know if this is interrupt 1 or interrupt 2. Okay, this is variable here. Here I just put zeros, okay? Here I just do initialization. I don't need to repeat what I said before. I just do here I did initialization. So I selected here the prescale to be 6, okay? If the prescale is 6, you can do the calculation by yourself. So it's going to be 24 megahertz divided by 6, sorry, which is 3 megahertz. This is F. So the time for one count, 1 over F, which is 1 over 3 microsecond. Is that okay? So you need to calculate how many counts you have. So for example, if I measure from here to here, I found it's 2,000 counts. Okay, in order to convert the number of counts to time, you have to multiply by this one. Is that okay? Because this is the time for one count. Is that okay? Anyway, so again, I'm gonna solve the lab now. So here, look what I did here, guys. I'm gonna wait here. I'm gonna wait until 2 interrupts happen, right? Because and then after 2 interrupts, I'm gonna do the calculation. I have to wait until 2 interrupts. Is that okay? Because I told you all what I need to know. I need 3 numbers. I need to know the count here, which is H1. I need to know the count here, which is H2. I need to know how many overflow from here to here. Once I have these 3 numbers, I should have these 3 numbers after interrupt 1 and interrupt 2. That's why I have to wait here. I have to wait until 2 interrupts happen. So when there is interrupt, it's gonna go and then it's gonna come, go and come. Once I have 2 interrupts, that means I already collected the numbers I need to calculate the time, right? That's why, as you see here, once I have 2 interrupts, I'm gonna come to here, I'm gonna do the calculation. That's it. I'm gonna say period. I'm gonna see this is the formula I explained before, the same formula. That's it. You can calculate the period this way. Very easy. Is that okay? So now, let's see what I have to write in the here. This is the interrupt subroutine, and this is the timer overflow. Okay. as you see here, before I forget, here in the beginning, the timer is disabled. I don't want any interrupts from the timer now, because I have to start counting overflows from here. That's why it should be disabled in the beginning. Now here I'm gonna enable once in this interrupt. You will see right now. So here, if in the first interrupt, first for sure, in any interrupt you have to clear the flag bit. I should not say this one. Now here you increment the interrupt, and now if this is interrupt 1 and this is if it is interrupt 2. Is that okay? So here every time this one is, so this one is going to be interrupted one time here and one time here. So maybe, sorry, I made a mistake. This one is a little bit mistake. So here I program this one to capture only rising. Is that okay? That means this one is I'm gonna calculate here, interrupted here and interrupted here. Okay. So this is interrupt 1 here, this is interrupt 2 here. Okay. Because here I programmed it to capture only rising. Is that okay? So, and this is the first part of the program. The first part is the lab. I want to count the time from here to here. Is that okay? So only I capture only rising. So one interrupt here, the second interrupt will be here. So here, in the first interrupt here, see what I did, guys? If it is interrupt number 1, what I can do? As I said, I'm gonna take the TC value, which gives you the count. What is the count here? I'm gonna put it in each one, okay? And then I'm gonna enable timer. Is that okay? Because I wanna start counting from here, overflows from here. Once you enable timer, every time there is overflow, you are gonna increment the overflow by 1. Is that okay? Okay. In the second interrupt, which is here, number 1, TC0 has to come to here. This is number 1. Number 2, I have to disable timer because I don't want to mess up with the overflow. I already have some value, I didn't use it yet. So if you forget this one, what's going to happen, this overflow is going to be incremented. Keep incrementing, right? I need to count overflow from here to this number. Number 2, I have to disable channel 0 as well. Why I have to do this one? Because maybe there is another rising is gonna come and mess up with each one and each. I didn't use yet each one and each 2. I didn't calculate it yet. You get what I'm saying? Same thing for overflow. So here, in case of interrupt 2, I have to make sure I have to disable this one so that I can use the correct, I didn't use it yet, so that I can use the correct value for overflow. Same thing. So I'm gonna, because I already finished the measurement for 1 cycle, okay? And then, once the interrupt is 2, well, I'm gonna calculate the period this way. Is that okay? Okay, guys? So, now, given this program, for the lab, what you are gonna do for the lab? What you have to do for the lab, you have to do 2 things. Number one, you have here, I do the measurement only 1 time. I want you to make it periodic. Okay? So what would I change if it is periodic? Number 1, this one has to be inside white because it's gonna be periodic. So this part here has to be inside white. This number 1. Number two. Here, I finished 1 round of measurement. I have to prepare for the second round of measurement. So what should I write here? After I finished 1 round of measurement, what should I write here? Number one, you have to clear everything again because I'm gonna start another round. Okay, this is number 1. You have also to clear, don't forget to clear the interrupt, also this one. So here, so after you finish the measurement, you have to clear all these values here, okay? Because I'm preparing for a second round. Is that okay? Also, you have to clear, what else I have to do? So I have, the timer is already disabled. I don't need to disable it again. It's already disabled. That's it. And then after that, I'm gonna enable, look here, I disabled the channel 0. So here, I'm gonna enable channel 0. Okay, to start the second round. Very interesting, very. Is that difficult? Okay, guys. Very interesting because enable, disable, interrupts. Look, very interesting. So in the very beginning, the timer is disabled in the very beginning. Okay. After two interrupts, after one interrupt, I'm gonna enable the timer. After two interrupts, I'm gonna disable the timer, and then I'm gonna disable channel 0 as well. After I do the calculation, now I wanna prepare for a second round of measurement. Okay, to do that, I have to clear these values. Actually, you don't need to clear. You have to clear overflow. You don't need to clear H1 or H2 because the new value is gonna be added. You don't need. So H1 and H2, you don't need, but overflow, yes, you have to clear overflow for sure because this one is increment, okay? Also, and then you have to enable, this one again for another measurement, okay? So this is one thing you have to do, very easy. Believe me, this is very easy. The second thing you have to do in this program is, after you do a measurement here, I already have the measurement in period, right? Just display it on the LCD. That's it, very easy, right? Display on LCD. Just display it on the LCD. I told you if you want to display it on number of counts, it's okay. If you want to convert it to time and display, that's okay. You got what I'm saying? Any question? Very interesting because you have now the program is not only one part, one piece. Okay, one piece of code. Now the program is written in 3 pieces. One part here, one part, and this is the typical case for microcontroller. One part here, one part here, and this one can enable this one, and also this one can disable this one, and also can disable itself. So somehow interesting. Okay. Any questions? So this is one part in the coming lab. Okay. Now I'm gonna do a very, very little modification on this one. Okay. So what little modification? Why you wanna do little modification? I'm gonna tell you. This one, what I did here, I capture rising because I capture rising. If I have a signal something like that, so actually I'm gonna measure the time from here to here. Is that okay? Because I'm only capturing rising. Is that okay? So now let me ask you a question. I wanna modify this program so that I wanna measure the time from here to here. Not so this is the modification I wanna do. So I wanna do this one, not this one. This program already did this one. Okay. So I wanna measure the time from here to here. What would I change? Okay, what would I change in this program to measure the time from here to here? Is that okay? Can anyone guess? And I'm sure the first guess will be wrong. So anyone can guess. So I want to measure the time from here to here. What would I change here in this program? No way. Someone has to guess. What would I change here in this program if I want to measure the time from here to here? One idea which is not good, or somehow tricky, yes.
Divide the time between
Divide the time each 1 by 2, or get the period divided by 2. That's not true because you assume it's 50% to do the cycle. That's not always the case. This is a good point because maybe some of you are still confused. Listen to me. So the idea here is, no, I'm not gonna change anything. I'm gonna do the same program. I'm gonna measure the time from here to here. And then this time, that's what this program is doing. This time I'm gonna divide it by 2. That's what you wanna do. This is true if you guarantee that this signal is 50% to do the cycle. This is not always the case. Okay? So the other case, what can I do, which is not good idea and which is somehow tricky? What I can do, I can change this one from rising edge to rising and falling. Okay, so if I do rising and falling, so I'm gonna have one interrupt here, I'm gonna have the second interrupt here, and that's it. All what I need two interrupts. That's all what I get. So instead of capturing only rising,
I'm gonna change the configuration here so that I can capture rising and falling both. Okay? No, this is not a good idea. It's somehow tricky. I myself, I tried to do this way in the beginning, and then I discovered, no, it shouldn't be this way. So even myself, I was confused about it, okay, in the very beginning. You got what I'm saying? Yes.
What if you change it after pressing it?
Yes. No, but you're right, that's what I will do. But my question is that why this is not a good idea? What is the risk here? The risk here, guys, is sometimes it can give you correct results, sometimes it gives you wrong results. It depends on where the signal starts, and I have no control on it. For example, if I start from here, so if I start counting interrupts from here, so I'm gonna capture this one, I'm gonna capture this one, and then I'm gonna measure this time. You get what I'm saying? This is a tricky part. However, if I start the calculation from here, I'm gonna capture this one, I'm gonna capture this one, and then I'm gonna calculate this time, which is correct. You got what I'm saying? So I have no control on this. So sometimes if you start, it depends on where you start, the signal is running. You know what I'm saying? So if the signal is not running or it's not changing, okay, you can just use both of them. Okay. So what? So just to be on this, you understand the problem, guys? So if you capture both, there is some risk that you are going to measure this one instead of this one. So this is wrong. This is what I want to measure. There is some risk there. Okay. Again, to be on the safe side, to be more specific, that's what I can do. Look here, guys, what I can do. In the very beginning, I'm gonna capture only rising in the very beginning, as normal. Once I come to rising, okay, in the first interrupt, I'm gonna change the configuration to capture falling. Yeah, so I have to write something here, that's true. So I have to write something here, okay? In order, I have to change configuration to capture falling. Yes, that's true, okay? I think I explain it. Yeah, that's what I'm saying here. If you want to measure something like that, so here, this is the assembly code for the program I taught right now. It's exactly the same thing, but in assembly. So what I'm saying here, this is the one I added here. So the one I added here, in the very beginning, in the code, I capture rising. In the first interrupt, I'm gonna change it to capture falling, as you see here. Is that okay? Okay. So this is assembly code. I don't want to spend time because this is exactly no difference. This is exactly the same code I explained right now. You have to wait for 2 interrupts. You have to count the number. It's exactly the same thing. Okay, so I don't want to spend time on this one. Another thing which is very tricky, listen to me, very tricky. I forgot to tell you, look here, guys. Here, so here, that's what you have to do in the coming lab. After period, so you have to display period, okay? And then after you display period, for sure, everything here has to be inside while, as I said, inside while. After you display period, number 2, you have to prepare for a new cycle of measurement. You have to prepare for a new cycle. And I told you the way you have to prepare for the new cycle. Number 1, overflow has to be 0, right? It doesn't matter. You don't need to clear this one. You don't need, because this one, I'm gonna write to it, so it's okay. It's the same thing for period. You don't need to clear it, okay? So number 1, overflow has to be 0. Number 2, the interrupts number has to be 0. This one. You have to make sure this one is 0. Is that okay? Number 3, you have to enable PT0 or input capture. Sorry, this is input capture 0. Channel, if you use channel 0, interrupts. Okay, that's it. No, it's not something very tricky is missing here. Very tricky. Yes. Yeah, this is okay. You're right.
This is if you measure from here to here, you're right. So here I have to change it to rising edge. You're right. However, I'm explaining this program. I want to measure from here to here, so I don't need to change anything. But you're right. This is a good point. Okay. If I want to change it again to rising, so I have to write it here. You're okay. There is another tricky point, very tricky. Okay. What you have to do here, and I think I explained it before quickly. Very tricky. Look here, guys. When we did this way, okay, and we ran the code, we honestly, in the beginning, I didn't thought about it. But we ran the program, we found the results are not correct. And then I learned it, what was wrong, okay? So what was wrong here? I thought, yeah, it's okay, everything looks okay. I'm gonna tell you what happened. When we ran this code, we found that the overflow is always one more than the correct value. You got what I'm saying? So we found that when we read this program, the overflow is always one more. That is because I disabled here, I disabled the timer, so there is no interrupt. But the interrupt flag was 1 because there was overflow. In the time I went back here, in the time I did the calculation, during this time the timer is running, right? So during this time, the time I display the periods, during this time the timer is running. So there was overflow. But this overflow is not gonna mess up with my overflow here because I disable interrupts. However, it's gonna make a mess for the next cycle. Why? Because what happens is that the overflow is 1. So the overflow is 1. So once I enable, once I enable the interrupt, once I enable here, once I enable the timer interrupt, what's gonna happen is once I enable it, it's gonna trigger interrupt right away because there is one old one. Okay, that is why it should not be here. It should not be here. It has to be here. Before you enable interrupts here, okay, you have to write this instruction here, right? So here, because I need to start the counting from here. So if the flag bit was 1 from the history, so I have to clear it because I have to start counting from here. So it's very tricky, right? So all what you have to do this one, you have to write it here. Is that okay? Any question? Okay. Okay. Now, so I give you one example about input capture. Now I'm gonna move to output compare. Here in output compare, as I told you, I want to generate a signal like this one, and should be the second part of the lab. In the second part of the lab, it's just a very little modification to the coming program here, to this program. Okay, very little modification. I told you, very easy. All what I have to do, guys, if I want to generate a signal like this one, what I need? Number 1, you have to convert this time. You have to convert this time to number of counts. You have to convert this count to number of counts. This is number 1. Okay. And the way you have to convert it using the prescale. For example, here if I select the prescale to be 8, that means if I do the calculation, so the time for each count 1/3. Okay. That means if I want to convert 300 microsecond to number of counts, I have to do this way. If I have to convert 700, I have to do this way. Okay. So once you convert the time to number of counts, as I said, all what you have to do here, you have to know, you have to use that variable to know if you are, there should be one interrupt here, one interrupt here, one interrupt here, and one interrupt here. In this interrupt is here, I have to do the same thing. Always in this interrupt is here, I have to do the same thing. And in this interrupt is, also I have to do the same thing, okay? So what should I do here in this interrupts? I have to say TC0 should equal TCNT plus 900 because the next toggle should be after 900. Is that okay? Same thing here. I can say TC0 should equal TCNT plus 2100, okay? You will see right now how I did it, okay? So again, I explain the program in assembly and also in C, but I'm gonna teach the C for now. So this is in C. Look here, guys. So here, as I told you, I'm gonna use a variable. This variable is called high or low. This one, this variable should tell me if I'm here or here, right? Here or here, right? So one value, for example, one value here and one value is here. So you will see right now, okay? So this variable has to tell me, okay? Number two, this is the high count. So in case of high, if I'm here, this is the value I have to use for high, and this is the value I have to use if it is low, for low, okay? So this is the value for high, this is the value of low, okay? And then here you have to do the calculations. You have to do the initialization here. You have to select the prescale and everything I explained before. I'm not gonna talk about this part. And then if you look here, guys, and then this is the main program. The main program is free. So the main program is free. You can write a task here. So you can write a task in the main program. Is that okay? This is because this signal is going to be generated by the output compare by this subroutine. So this interrupt subroutine is going to generate the signal. So let's see how it works. Very easy. Look here, guys. Here I use number 13 because I'm using a channel 5. If you go to the table I explained before, 13 is the number you have to use for a channel 5. Okay. So as usual, you have to clear the flag bit as usual. And then look here, guys, high or low. So the signal is the signal high or low, right? If it is equal to 0, okay, that means I have two values, right? So here 0, here is 1, okay? So here, if it is 0, so if it is 0, so I'm gonna output the high. So I'm gonna output the high value. TC5 equal TCNT plus high value, right? And then I have to put 1. So that next interrupt, I'm gonna come here. Next interrupt, I'm gonna come here. And in next interrupt, I'm gonna put the low value, low count. Is that okay? So you can see, guys, very easy. Look here. Okay. So in one interrupt, I'm here. In next interrupt, I'm here. In one interrupt, I'm here. Next interrupt, I'm here. Yes. How you did it? Because every interrupt, I change high or low. So if the 0 becomes 1. Why I put 1? Because next time I have to come here. Next interrupt here, next interrupt here, next interrupt here. So one interrupt here, one interrupt here. Is that okay? And in every interrupt, I toggle. So here I make the decision, I make the action toggle. So every interrupt, you toggle the signal. Is that okay? Toggle the signal this way, and you say next toggle after the high count here, next toggle after the low count, the count here, the count I have, which is 900 and 100. Is that okay? Again, this one should work fine if if you begin from 0. So if you begin from 0, and every time you toggle, I think it should be okay. However, maybe there is one risk, maybe there is a risk that you generate something like that. It's going to be opposite signal. It's going to be maybe there is a risk to do something like that because I toggle, right? It's the same problem I had before. We just toggle, right? So if I won, you are going to toggle. Then you are going to toggle. So, sorry. I think it's going to become, yeah, there is some risk, yeah, to generate something like that, okay? So again, I think we did this one. It was okay. It worked. Again, if it doesn't work and you have a problem, very easy. All what you have to do, I can write one instruction here as well. What I can say here, I can put the action. What action you want to take? This is the high count. Okay. So I can say here the action I want to take the pull bin high. So that pull it low, right? So that after the high count, this is the high count. So here, sorry, maybe made a mistake. So this is the high count. I'm here. Okay, this is the high count. I think I made a little mistake. I think this is 0 and this one. So from 0, I will come to here. This is the high count, which is 900, and this is the low count for 2100. Is that okay? So if I'm here, I'm gonna say, please next interrupt after 900. That's exactly what I'm saying here. That's exactly what I'm saying here. Please make next interrupt after 900. Okay, this is number one. Number two, I'm gonna also say I can add one instruction here, and also after 900 bullet low, I can write here an instruction to bullet low. Same thing here. Once I come here, guys, I can say next interrupt after 2100, and then I can say the action should be pull the pin high. Anyway, you can do that as well. Any questions? So let me, very easy, look here. This interrupt subroutine is going to be interrupted 2 times in every cycle, 2 times. One time here, one time here. Okay? If I'm here, I'm going to say, please, next interrupt should be after 900. Here, next interrupt after 2100. Is that okay? And also, you can change the action if you want. Okay. The interesting thing in this program is, look here, guys. The reason I put the high count and the low count outside here, the reason is, if I want to generate different signals, so this program should generate a signal something like that. What if I want to generate a signal something like that? All what you have to do, you can use exactly same program. All what you have to do is just to change these numbers. For example, I can say 3000, 3000. So in this case, the duty cycle is 50% because high is 3000, low is also 3000, and so on. Okay. Same thing, you can generate a signal like this one. I can say the high is 2100, and this one is 900. And I think this is in the coming lab. So in the coming lab, one part of the lab is to output this one, and output the opposite. To output the opposite, all what you have to do just to change these numbers. That's it. Any questions? Again, if you go back to assembly, again, this is exactly what, nothing is new. It's high and low, you have high count, low count, everything is similar to what I explained here, okay? But in assembly code, okay? So here, again, by changing these numbers, you can change the frequency. Also, you can change the frequency. Also, you can change the duty cycle. Okay, so you can change the frequency and also the duty cycle. Is that okay? One more thing, very little modification. Look here, guys. If the interrupt is enabled, if this channel 5 here I don't need the timer interrupts. Only I need channel 5 interrupts. Okay, so here I don't need the channel timer. Only channel interrupts. As long as this interrupt is enabled, as long as this one is enabled, you can continuously generate a signal. It's going to be continuous as long as it's enabled, right? What if I want to stop for some reason? I want to stop the signal. Okay, I don't want to generate a periodic signal forever because I'm saying I want to stop it. Very easy. All what you have to do just disable interrupt here. That's it. If you disable interrupt, you're not going to see a signal, right? Because this signal is made by the interrupt. Any question? That's what I did. So here you are going to generate periodic signal. Okay, what if I want to generate 10 cycles and after 10 cycles it has to stop? I want to do something like that. Very easy. Look what I did here. It's the same program, but I just added this code here, very small code. So here, in every interrupt, I'm going to decrement the count. Once the count equal to 0, so stop generating the signal. Is that okay? So if you have a signal, if I want to generate, for example, 10 cycles, okay, and after 10 cycles, I want to stop generating the signal. For some reason, I want to generate 10, and then it's not going to stop. So the way I can do it, I'm going to put some value in count here, and then every time it's going to be decremented by 1. Once it is 0, so channel 5 is disabled. If channel 5 is disabled, so there is no signal because the signal is made by channel 5. Is that okay? But what value I have to put here in count? Okay, if I want to generate 10 cycles, should I put here 10? No, it has to be double. So it has to be 10 times 2. Why? Because remember, in every cycle, it's going to be interrupted 2 times. 2 times. In every cycle, it's going to be interrupted 2, right? So if you want to generate 10, so it has to be, you have to put here, I'm going to have 20 interrupts. Is that okay? Any questions? Okay. The last part here, the last program I'm going to teach now is, you remember the police siren, the police siren, right? What we did, I did the police siren, I put it in the main program, right? So the main program, that's what I did in chapter 3. Now I want to teach, what about, can I use output compare to generate the police siren? Yes, this is what this program is about. I can use output compare to generate the police siren. Is that okay? And then, if you want to stop the police siren, just disable output compare. You got what I'm saying? So you can move this test from the main program. You can put it in one output compare channel. Is that okay? And then, if you want to stop it, you just disable, right? Disable it. Okay. So how can we do it? I did it in 2 different ways. The first way, it's not good idea, but it's like a step forward. It's one step. So I'm going to show you how I did it, but it's not good idea. But I'm going to tell you how I did it. Okay. Look at this program here. This program here. By changing this number, I can generate different frequencies, right? By changing this number. That's what I did. So I'm gonna see how I made it, okay? So why I'm gonna now teach 2 programs, okay? One program I don't think is a good idea. This is this one, and then I'm gonna teach the better version, okay? Here in the main program, I'm gonna do something like that in the main program. I'm gonna say, set the value of high count and low count to generate 500 hertz. Then I'm gonna wait half a second, and then I'm gonna set the value for high count and low count to generate 250 hertz, and then I'm gonna wait half a second. This is what we did in chapter 3, the police siren. Half a second and half a second, right? So what I did, I'm gonna use exactly the same program I taught right now, exactly the same program. However, I'm gonna change the value of high count and low count. One time I'm gonna select some values to generate 500 hertz. Next time I'm gonna check for half a second, and then I'm gonna change it. Okay, so this is, so look what I want to say. So number 1, I'm gonna use exactly same program here. I'm gonna use exactly same program, okay? But I'm gonna add, all what I'm gonna do, I'm gonna add this part to the main program. Instead of here, the main program was empty. The main program was empty here, while, so here, I'm gonna add this part. Look what I did. I'm gonna say, high count is 3000 and low count is 3000. Okay? Because 3000 and the 3000 should give you 1 millisecond signal. So this one, I'm going to generate 1 millisecond. 1 millisecond, 1 millisecond. Again, you have to do the calculations. Okay? So I'm going to keep this part for half a second. Then after half a second, I'm going to change high count to low count to 6,000. Is that okay? So now I'm going to generate another signal, 2 millisecond and 2 millisecond. So then I'm gonna keep repeating it. So, okay, and again, who is using, so here I just set high count and low count. I just set them. Who's using them output compare? So output compare is using them. So just in the main program, I put some values, and then output compare is gonna generate a signal with these values. Is that okay? Very interesting. I see it very interesting. Why? Because output compare is generating a signal, okay? And then I can change the signal later. For some reason, I can change the signal, right? That's what I did. So here, by changing the number I have, output compare is working, right? Output compare is working, and output compare is using these 2 memory locations. By changing the number I put here, I can generate different signals, okay, for some reason, okay? And again, remember, the buzzer was connected to BT5, remember, is that okay? So it's already, so here, if you want to use the buzzer, so you have to use channel 5, right? Because the buzzer is connected to channel 5, okay? So you have to use channel 5. Again, so why you think this is not a good idea? Can anyone tell why I'm saying I can do this way, but I don't like it? I can say quickly because we don't have much time. The reason I don't like it because now for one task, I'm gonna use the main program. Also, I'm gonna use interrupt. It doesn't make sense. I wasted I can do two tasks, right? So, but what you can learn here, guys, is the same program here that generates signal. Maybe for some reason you can change the signal later for some reason. So still you can do it in the main program. Something happened, you want to change the signal for some reason, okay? You still can do it in the main program. Next time, the reason I'm saying this is not a good idea, as I said, because you already, the main program is I'm gonna use two locations, okay? Next time I'm gonna explain how can you do the same program, but only using output compare. So I'm not gonna use the main program. So to make the police siren, I'm gonna only use output compare. That's what I'm gonna explain next time, okay, guys? Okay, see you next time.